On December 5th, as ThreeI Atlas quietly moved closer to Earth, its light began to fade. At first, astronomers saw ThreeI Atlast as just another faint dot in the survey data. But when they stacked night after night of observations, Atlast's orbit emerged as a razor-straight, surgically clean line far too precise for any ordinary natural object. The software was forced to halt flag ThreeI Atlast in red and demand a manual review. Almost immediately, the big telescopes were turned toward this new guest. In every subsequent exposure, Atlas glided exactly along the predicted track, as if it were following a pre-programmed flight path. Its brightness and light curve looked calm and harmless, but the geometry of its trajectory told a different story. This didn't behave like a rock in free fall, it behaved like a guided approach. So what exactly is happening when ThreeI Atlas draws closer to Earth, while simultaneously growing dimmer? Is this the signature of burning disintegration, or the sign of something entirely different at work? Let's start peeling back those layers of mystery one by one. ThreeI Atlast first appeared as a routine detection, and within minutes the routine broke. The Atlas network swept the sky as usual, but when the software replayed the night, Atlast refused to look like noise. On the screen, ThreeI Atlast did not wander. Atlast cut a single razor-straight line through the starfield so precise that the tracking code froze mid-run. The system halted, marked ThreeI Atlast in red, and demanded a manual check. Analysts overlaid multiple nights and watched Atlast trace the same immaculate stroke frame after frame, as if following a ruler laid across the solar system. Where distant visitors normally drew messy arcs, Atlast carved a path so clean it looked artificial. Atlas did not jitter, did not sag toward gravity. Wells did not show the tiny drunken steps of a drifting shard. Coordinates went out to larger telescopes and mirrors turned toward ThreeI Atlast. In every new exposure Atlast advanced with the same unhurried, unbending motion, sliding exactly where the propagated point said it would be. The brightness of ThreeI Atlast stayed smooth, the light curve quiet, almost soothing to the eye. The graph said there was no danger, but the geometry of Atlas said something else. Hidden inside those calm numbers was a visitor that behaved less like a rock in free fall and more like a course being flown. What unsettled the first analysts was not noise or chaos, but how little randomness seemed to cling to Atlast. On a sleeping planet, city lights dimmed room by room, while ThreeI Atlast wrote its quiet line across the sky. Above oceans and continents, clouds drifted and reformed, and still, Atlas moved in the same deliberate whisper of motion. By the time the Discovery Circular went out, Atlast already held a tiny invisible appointment with Earth's orbit. The story of that appointment and of how Atlast would keep adjusting to meet it was only beginning. From the first reconstructed orbit, astronomers saw that ThreeI Atlast was not wandering blind through the solar system. The calculated path of Atlast curled into a smooth, low eccentricity arc that almost hugged the track of Earth around the Sun. Night after night, new measurements dropped in, and each update nudged the solution for Atlast into sharper focus. Instead of the stretched falling trajectory expected from a random interstellar stone 3, Atlas traced something closer to a shared lane. Software routines tried to fit Atlast with familiar models testing gravitational captures and distant planetary kicks. Every time the equation settled, ThreeI Atlast still came back with a line that seemed too neat to aligned with Earth. Far from the Sun, small discrepancies appeared in the velocity vector of Atlas' tiny sideways pushes that resisted easy explanation. Under pure gravity, ThreeI Atlast should have fallen along a slightly different curve, but the residuals stayed stubborn and structured. Analysts rechecked star catalogues, recalibrated detectors, and stripped out possible biases that might have bent the numbers around Atlast. When the dust of uncertainty cleared the remaining pattern, still suggested that ThreeI Atlast was steering toward a particular corridor in space. In control rooms lit by soft monitors, people watched the projected point of closest approach slide along Earth's orbit with Atlast. The missed distance was large enough to be safe yet unnervingly tidy, as if ThreeI Atlast had chosen a respectful passing lane. Outside those rooms, the world turned slowly, unaware that a distant visitor was refining a path beside the planet's own trail. Somewhere in the dark, ThreeI Atlast followed a curve that looked less like a fall and more like an intention. The question of who or what held that intention would wait moving forward with Atlast into the deeper chapters of the story. when the James Webb Space Telescope finally turned toward 3 Atlast, astronomers expected a familiar song of dust and ice. The instruments were tuned for the usual fingerprints of comets, for the quiet lines of water, carbon monoxide, and simple rock. Instead, the first spectrum from Atlast came back strained and strange, as if the light had passed through a lattice rather than a cloud. 3I Atlast showed broad, smooth regions where absorption bands should have bitten down and sharp bites where the models predicted gentle slopes. Teams reran the pipeline, suspecting a calibration error long before they suspected Atlast. Reference stars were checked, flat fields reprocessed, and dark frames compared all to see whether something other than 3I Atlast had misbehaved. When the corrected spectrum returned, unchanged attention shifted back to Atlast and the peculiar gaps in the rainbow. Those gaps lined up more closely with the response of dense, ordered structures, something like overlapping crystals or engineered metallic foams surrounding 3I Atlast. Laboratory libraries built from years of heating rocks and ices failed to produce a neat match for Atlast. High-density alloys and exotic metallic mixtures gave closer echoes, but nothing on the shelves fit 3I Atlast in a single satisfying overlay. In meeting rooms, people began describing Atlast less as a snowball and more as a shell, a vessel with a skin that talked to starlight. The language remained careful, but the mental picture of 3I Atlast had already shifted from rough stone to quiet architecture gliding through space. Outside those rooms, the universe stayed serene, and Atlast continued along its poised curve, reflecting that odd spectrum into the dark. The next step was to listen not just to the light that bounced from 3I Atlast, but to the radio whispers that seemed to rise from within. The first hint that 3I Atlast was speaking arrived as a faint repeating pulse. On long, quiet bass lines, receivers noticed a narrow band of radio brightness that rose and fell with serene regularity, tracing a small heartbeat from Atlast. The lines were sharp, sitting on a quiet background where cosmic noise usually froths and crackles around objects like 3I Atlast. Engineers checked for interference from satellites, ground transmitters, and known spacecraft, but nothing local lined up with the timing that followed Atlast across the sky. When they folded the data, the pattern resolved into a gentle stair-step, a bright phase, then silence repeating every 53 minutes as Atlast moved along its track. The Deep Space Network began to schedule more dishes toward 3I Atlast, letting the planet's rotation hand the signal from antenna to antenna so the pulse would not be lost. At first, the team treated the pulse as a curiosity tied to the environment around Atlast, some quirk of plasma or magnetic wake. But when they traced the direction of arrival, the beams converged not on empty space, but precisely on the coordinates where 3I Atlast sat that night. The frequency drift corrected itself as Earth spun, so the pulse stayed pinned in place in the rest frame of Atlast. Every adjustment that Earth's motion imposed was answered in reverse by the steady rhythm, as if 3I Atlast were quietly compensating to remain easy to hear. Pattern hunters turned loose neural networks and old-fashioned code breakers on the stream pouring in from Atlast. Inside the sequence, they began to see prime numbers, simple ratios, and then more elaborate combinations that described orbital periods and distances in the system 3I Atlast was crossing. One cluster of ratios traced the year of Earth, the distance of Earth from the Sun, and the slight oval of the planetary path that Atlast was now shadowing. The numbers pointed not to the star but to the moving world, as if 3I Atlast had built a small map with a circle drawn around Earth. In internal notes, some authors wrote that the signal from Atlast appeared to encode not just where the planet was, but how long it had been circling there. That quiet suggestion implied that 3I Atlast carried a memory older than any human archive, and that Atlast had chosen to reveal a fragment of that memory now. For the few who read those notes in the stillness of late offices, the realization brought a soft, unsettled calm rather than panic. The universe around 3I Atlast had not changed, but the sense of being noticed, measured, and gently addressed settled over the data like a second invisible spectrum. Outside the documents, nothing was announced. To the wider world, 3I Atlast remained only a visitor with an unusual orbit. Deep inside the networks, however, the pulse continued to tick every 53 minutes, and 3I Atlast kept speaking in a language that was only partly understood. Whatever remained hidden in the unbroken segments of the signal would have to wait until other layers around Atlast were uncovered. Those layers, wrapped like a sheath of radio and geometry around 3I Atlast, were only just beginning to be seen. The deeper the arrays listened, the clearer the space around 3I Atlast began to sound. Instead of a single narrow line, the spectrum near Atlast filled with a faint comb-like structure, as though a band of frequencies were being brushed in parallel by ThreeI Atlast. Engineers plotted the strength of those tones against distance and angle, watching a pattern blossom around ThreeI Atlast like a hollow shell. In all directions at a particular radius, the signal from Atlast rose and fell together, outlining a kind of radio sheath that surrounded the moving body. When images from wide-field telescopes were stacked, small dark points appeared near the path of ThreeI Atlast. Those points moved with Atlast night after night, holding fixed separations as if ThreeI Atlast were travelling with a quiet convoy. Each companion remained dim, geometric, and stubbornly consistent in formation around ThreeI Atlast. Natural fragments should have drifted, collided, or lagged, but the faint escorts of Atlast flew their tidy pattern with a patience that did not fade. Analysts mapped the positions and found a loose ring and a leading wedge in front of ThreeI Atlast, like a shallow bow and a trailing guard. The radio sheath wrapped around the whole group, suggesting that Atlast and the companions together formed a single working architecture. In an internal summary, one paragraph described ThreeI Atlast as a vehicle-like object, accompanied by multiple co-moving bodies in a structured arrangement. Another line, even shorter, said that the approach of Atlast to Earth's orbit was statistically inconsistent with a random encounter. The language stayed cool, but the conclusion about ThreeI Atlast settled over the team with a quiet weight. Somewhere beyond the formal phrasing, people began to picture Atlast less as a wandering stone and more as an organised visitor passing through. To understand what such a visitor might be prepared to do, attention turned next to the logic hidden inside the signal of ThreeI Atlast. In that logic, the unfolding intention of Atlast would become harder to ignore. The longer the team listened, the clearer, deeper rhythm inside the signal from ThreeI Atlast began to appear. What first sounded like a simple repeating pulse from Atlast slowly unfolded into a pattern with steps and layers. When analysts stretched the timeline and stacked many cycles together, the stream from Atlast separated into clusters of 3. Each cluster around ThreeI Atlast carried 3 shapes, 3 tones, 3 levels of energy returning again and again with patient precision. Machine learning models were turned loose on the data feeding on the triplets that Atlast kept sending across the dark. The algorithms mapped how each part of the triplet from ThreeI Atlast shifted in response to small changes in the environment. Whenever a parameter in the plasma around Atlast changed, one branch of the triplet grew brighter, while another faded. Whenever Earth's motion altered the apparent frequency, the next group from ThreeI Atlast arrived slightly adjusted, as if acknowledging the shift. Gradually, the team realized that the triplets from Atlast behaved less like a heartbeat and more like lines of code. One motif from ThreeI Atlast seemed to stand for "if this condition holds," while another motif answered with "then move to this state." On whiteboards, researchers drew flowcharts that mirrored the triplets ThreeI Atlast was sending, with arrows moving between boxes of logic. Each arrow traced a possible reaction that Atlast might take in response to subtle changes in field particles or approaching objects. The picture that emerged was not of a passive beacon, but of a program running quietly within ThreeI Atlast. That program inside Atlast appeared to be waiting for certain thresholds ready to branch when the universe around Atlast crossed them. For some, the thought brought a strange comfort, as if ThreeI Atlast were following rules rather than whims. The next question, which would shape human response, was how much of that logic could be shared with the world without saying too much about Atlast. The day came when someone had to stand at a podium and name ThreeI Atlast out loud. Cameras stared back, lenses blinking under the lights, while the director of the agency read a statement about a distant interstellar visitor. In the prepared remarks, ThreeI Atlast was described as a non-natural object following an unusual orbit near Earth's path. The wording said that Atlast showed anomalous dynamical behaviour, and that agencies were monitoring Atlast closely with no immediate threat detected. Numbers were chosen carefully trimmed down to basic distances, speeds, and a safe miss distance for ThreeI Atlast. The statement did not mention that the signal from Atlast carried a repeating timestamp, a quiet countdown nested in the triplets. Behind closed doors, a separate document traced how that timestamp from ThreeI Atlast predicted an arrival at a very specific corridor in space. The lines showed when Atlast would slip into a region near the Sun-Earth L2 point, and when the internal logic of Atlast might change state. On live feeds, the world heard reassurance and saw calm faces speaking about ThreeI Atlast in measured tones. Questions focused on familiar comparisons, asking whether Atlast was more like a comet, or like the earlier interstellar objects that briefly visited. The people who had read the deeper analysis felt a different quiet as they watched ThreeI Atlast appear on the screens. For them, 3I Atlast was already a schedule, a program moving toward a stored appointment that nothing in human hands could cancel. When the microphones were switched off, the room emptied slowly and the hallways returned to their usual low murmur about Atlast. Outside the building, the sky looked unchanged, hiding the path that 3I Atlast was already following toward its rendezvous. The next step, unspoken in public, would be to send a small constructed visitor of Earth's own to meet 3I Atlast on the way. Long before the public heard the name, the vehicle planners had already accepted that 3I Atlast could not be ignored. The quiet logic inside at last, the countdown and the approaching timestamp forced a decision. Engineers were told to design something small, fast and simple that could meet 3I Atlast in deep space. Old mission plans were opened, mothballed, hardware was reconsidered, and pieces from cancelled projects were quietly reassigned to Atlast. The probe that emerged on paper was lean, little more than a bus of instruments, and a high-gain antenna pointed toward 3I Atlast. Propulsion was pushed to its limits, every kilogram counted, so the vehicle could reach the corridor ahead of Atlast in time. In closed clean rooms, technicians assembled the craft under schedules that matched the ticking timestamp from 3I Atlast. Every completed subsystem shortened the gap between Earth and the rendezvous point, where the vehicle would drift and wait for Atlast. Launch came at dawn almost unnoticed among other rockets climbing through the atmosphere toward orbit and beyond Atlast. Only a short line in an internal manifest mentioned that this particular payload was dedicated to tracking 3I Atlast. Once free of Earth, the vehicle unfolded panels, aligned antennas, and took its first long stare toward Atlast. Navigation teams began feeding tiny course corrections to keep the probe on the narrow path that 3I Atlast was predicted to cross. In simulation, the two paths converged like threads being woven together, the vehicle's line gently intersecting the curve of Atlast. The plan was simple: arrive first, float quietly, and let 3I Atlast reveal what kind of environment it carried around itself. As the vehicle closed the last millions of kilometers, the space near 3I Atlast began to feel wrong. Sensors that had seen only quiet vacuum suddenly reported gradients, gentle slopes in energy and direction that all pointed back toward Atlast. The field instruments traced a boundary, a soft rise in intensity that wrapped in a smooth shell around 3I Atlast. To navigation, the region behaved as if Atlast had drawn an invisible contour through nothing, a surface with no matter but a clear edge. When the vehicle crossed that contour, tiny deviations appeared in timing beacons and gyros that looked back toward Atlast. Clocks slipped by, microseconds, star trackers near Atlast saw stars lean by fractions of a pixel, as if light had bent without mass. The data did not match any known bow-shock magnetic bubble or plume from 3I Atlast. Instead, the equations implied a constructed geometry, a deliberate arrangement of fields like a room outlined in force with Atlast at its centre. Deep inside that room, 3I Atlast remained calm, its trajectory unchanged, its triplet logic still cycling. The vehicle felt only a soft push sideways, a suggestion that it stay near the wall rather than approach closer to Atlast. For the team, the discovery turned Atlast from a visitor into an architect, something that could shape empty space into structure. A quiet awe mixed with unease as they watched. 3I Atlast hold its invisible boundary without a single visible panel or hull. The next maneuver would test how that architecture reacted when the vehicle tried to press deeper toward Atlast. With every command uplinked, the small craft edged forward, and the story of 3I Atlast moved toward its first clear response. The vehicle edged inward, adjusting thrusters in tiny bursts, testing how close 3I Atlast would allow a guest to come. Telemetry flowed in smooth lines, and the craft's trajectory bent gently along the invisible wall that 3I Atlast had drawn. Then a single pulse arrived, brief and clear, without warning tones or violent spikes from 3I Atlast. Acceleration sensors registered a firm shift, as though the vehicle had been picked up and set down again farther from Atlast. No shockwave rippled through the hull, no debris cloud flared between the vehicle and 3I Atlast. The math showed a change in position without a matching history of force, as if Atlast had rearranged the outcome rather than pushed on the way there. Engineers replayed the sequence and found only a clean before and after around 3I Atlast. One frame showed the vehicle near the boundary, the next placed the craft safely outside the field drawn by Atlast. In debriefs, language grew careful, describing a non-contact displacement associated with the architecture around 3I Atlast. Privately, many pictured a gentle hand moving a fragile object off the edge of a table, a warning rather than an attack from Atlast. The vehicle's course was reset to skim the outer contour, this time respecting the distance selected by ThreeI Atlast. From that safer track, instruments continued to watch how the field changed as Atlast moved along the pre-computed path toward L2. The encounter left a new understanding of how ThreeI Atlast enforced boundaries without scars or wreckage. The next reports would have to follow Atlast not just to the invisible wall, but to the place where ThreeI Atlast seemed ready to act on a planetary scale. At the exact second predicted by the timestamp inside its signal, ThreeI Atlast slowed, rotated, and came to rest in the calm gravitational pocket of Sun-Earth L2. Every adjustment unfolded with mechanical grace angles refining themselves by millimeters, timing down to fractions of a second until Atlast hung in stable suspension behind Earth's orbit. Telemetry from the vehicle showed Atlast unfolding into shapes that shimmered like molten geometry edges sliding through one another without fracture. Panels or perhaps membranes spread outward and caught the solar wind in silence, forming a structure wider than the International Space Station, and yet almost invisible, except for faint scattering around Atlast. Then a narrow beam emerged, pure, steady, not light, not radio, projected downward from ThreeI Atlast toward a coordinate that did not exist on any map. It intersected the invisible threads of Earth's magnetic field, coupling directly with the planet's geodynamo, sending faint pulses that circled the poles like ripples across water. Instruments around the world recorded an unexpected surge in geomagnetic activity, exactly synchronized with Atlast's emission. Auroras expanded beyond their usual latitudes, power grids flickered, and compasses drifted in rhythm with the pulses coming from Atlast. Analysis of the beam revealed modulated sequences matching the conditional logic seen earlier in the triplets from ThreeI Atlast. Each segment resembled a command measure correct executed across the magnetosphere, as if Atlast were running a planetary calibration. The vehicle, now holding distance, watched as Atlast's frequency slowly decayed the beam, fading to a thin trembling line that dissolved into background space. Within hours, magnetometers on Earth began to settle into new baselines, quieter, more stable, as if a long-standing imbalance had been erased by ThreeI Atlast. Teams studying the final data called the operation a geomagnetic repair algorithm, though none could explain why Atlast would care to perform it. Before leaving, ThreeI Atlast transmitted one last compressed phrase inside its signal loop, a combination of constants that, when decoded, read, "Preserve the cradle, prepare the path." As months passed and observation logs grew thick, ThreeI Atlast offered a quieter puzzle to the people watching. Measured night after night, Atlast should have brightened slightly as geometry swung at last closer to Earth. Under simple rules, a visitor like ThreeI Atlast ought to behave like a distant car approaching on a dark road. Draw nearer, appear larger, scatter more sunlight. That is the ordinary script written for guests like Atlast. Instead, the numbers for ThreeI Atlast bent in the opposite direction. Photometry showed a slow, steady loss, and by the time Atlast had advanced on its track, more than a third of the apparent light had slipped away. Telescopes recalibrated, sky flats were checked, and comparison stars around ThreeI Atlast were measured again and again. The surrounding field held steady while only Atlast thinned, as if ThreeI Atlast were quietly dimming itself on purpose. Some models suggested that as Atlast moved away from the sun, frost might retreat and reflective areas might shrink. But the timing of the fade and the grace with which ThreeI Atlast softened in brightness refused to line up cleanly with that simple picture. On plotting screens, the light curve of ThreeI Atlast looked like a long exhale, a gentle slope downward instead of the expected slight rise. The paradox for Atlast was not violent or sudden. It was a calm refusal to match the rules of perspective. In late-night offices, people stared at the graphs and imagined panels on ThreeI Atlast, folding inward or surfaces deliberately turning dark. No such structures could be seen, yet the behaviour of Atlast invited those hushed speculations. Outside, the real sky stayed clear and indifferent, while ThreeI Atlast continued to grow nearer and fainter at the same time. Between those two motions, approach and disappearance, lay the next set of questions that would guide how Atlast was watched in the weeks ahead. Closer inspection of the images around ThreeI Atlast brought the second surprise. Behind the bright core, Atlast trailed a tail that refused to look tidy. Instead of a smooth, glowing streamer, the tail of ThreeI Atlast broke into clumps and gaps. Sections of the plume near Atlast appeared ragged like torn fabric drifting behind a moving ship. Deeper stacks of exposures revealed a stranger feature linked to ThreeI Atlast. A faint, sharp streak extended toward the sun, an anti-tail, cutting back against intuition. Under normal conditions, dust and gas should sweep away from the star, not toward it from Atlast. Yet the geometry showed the anti-tail lined up with the orbital plane of ThreeI Atlast. Modelers tried to reconstruct how ejecta from Atlast might settle into that precise sunward line. Their simulations hinted that particles leaving ThreeI Atlast at specific times and angles could create the reversed blade. In those same frames, brightness along the tail of Atlast surged and faded in broken segments. The changes suggested that ThreeI Atlast was not shedding material steadily, but in pulses and bursts. Observers imagined vents on Atlast opening and closing, or fractures waking and sleeping along the surface. Each imagined release from ThreeI Atlast painted another knot or gap into the tail's loose weave. For those watching through long nights, the view around Atlast felt strangely alive. Patterns in the tail of ThreeI Atlast rose and unravelled like breath visible in cold air. Nothing in the ragged plumes screamed danger. ThreeI Atlast simply refused to behave like a quiet melting snowball. The broken tail and reversed blade instead whispered of timing choreography and choices being made by Atlast. Those whispers nudged attention toward the deeper rhythms in the light of ThreeI Atlast. In the data that followed, Atlast would show a heartbeat more regular than its own torn wake. Amid the ragged tail of ThreeI Atlast, a different kind of order emerged. When observers plotted the brightness of Atlast over many nights, a clean rise and fall appeared again and again. The peaks and valleys from ThreeI Atlast returned every 16 hours, as precise as a mechanical clock. Independent telescopes across continents all saw the same quiet breathing of ThreeI Atlast in their light curves. Random jets from an ordinary comet would wander in phase, but the cycle tied to Atlast refused to drift even by minutes. Week after week, the pattern of ThreeI Atlast rose at the same phase angle like a heartbeat locked to an inner metronome. Modelers tested spins, misshapen cores, and tumbling slabs that might explain the pulse from Atlast. Every geometric trick failed once they remembered that most of the light around ThreeI Atlast came from the diffuse coma, not a compact core. For some, the regularity of Atlast felt oddly calming, less like instability, and more like a deep, slow breath laid over the data. Realizing that the pulse rose from the gas itself rather than a spinning stone pushed attention toward new questions about how Atlast was being driven. Hubble's sharp vision finally separated the bright blur of ThreeI Atlast into a core and a surrounding cloud. At the center of Atlast, the supposed solid nucleus resolved into a tiny point far smaller than many had guessed. Calculations showed that the core of ThreeI Atlast was only a few kilometers across a grain inside a lantern. Less than 1% of the total light came directly from that kernel. Almost everything around Atlast shone from the coma alone. That meant the 16-hour pulse of ThreeI Atlast could not be blamed on a spinning lopsided rock. Even if the nucleus of Atlast tumbled, its faint contribution could not drive such a strong regular modulation. Attention turned outward to the gas and dust that wrapped ThreeI Atlast in a glowing veil. If the coma was breathing, then somewhere near the surface of Atlast, the supply must be opening and closing on schedule. Scientists proposed that vents on ThreeI Atlast might switch on when certain regions face the sun, then fall quiet in shadow. Each activation would launch a fresh plume from Atlast into space, thickening the halo and brightening the curve. Given the flow speeds, an individual packet of vapor from ThreeI Atlast could travel tens of thousands of kilometers in one cycle. By the time the next venting occurred, the previous shell from Atlast would already be fading at the edges of the cloud. Taken together, the repeating shells from ThreeI Atlast would create a cosmic heartbeat, layers of breath pulsing outward in slow motion. The idea did not prove intent, but it gave a picture of Atlast that felt oddly alive. In the soft graphs and time-lapse images 3, Atlast no longer looked like a static monument of ice. Instead, Atlast resembled a small world, exhaling in long, measured sighs, keeping time with a rhythm older than any clock on Earth. While major observatories scheduled scarce time for ThreeI Atlast, a quieter network formed in backyards and on rooftops. All over the world, small telescopes turned toward Atlast, capturing grainy but persistent images night after night. Through these modest mirrors, ThreeI Atlast appeared as a soft core and a restless tail changing from one evening to the next. Every new stack of frames from the amateur community showed Atlast with slightly different knots angles and bright patches. Professionals used those timestamps to fill gaps between their own observations of ThreeI Atlast stitching a near-continuous record of behaviour. Because the world kept spinning different longitudes, handed Atlast from one small telescope to another like a relay. Over that growing archive, a more practical concern emerged around ThreeI Atlast. The geometry of the orbit was closing, and models showed only a narrow 2 or 3 week window when Hubble and Webb could safely stare at Atlast. Beyond that window glare from the Sun, and the steady fading of ThreeI Atlast would push the visitor below useful spectroscopic limits. To lose that chance meant accepting that Atlast might pass without ever revealing a clean chemical fingerprint. In late messages and quiet forums, observers urged that the great mirrors be aimed in time at ThreeI Atlast. The plea was not loud, only steady a collective wish that Atlast be truly seen before drifting beyond reach. For those lying awake under the same sky, the thought of Threen, Atlas sliding through such a small opening in time, added a gentle urgency to the calm. Among all the slow motions of the heavens, this was one moment when watching or looking away might change how Atlast was remembered. Long before any telescope named ThreeI Atlast, the object had already crossed a cold ocean of stars. Between sunlit systems, Atlast travelled through radiation storms, micrometeoroid swarms, and the thin fog of interstellar gas. Every grain of dust that struck ThreeI Atlast carried energy tiny but relentless over millions of years. Each impact that might have cracked a weaker body instead left only faint scars on Atlast. Simulations of the orbit suggested that ThreeI Atlast had fallen past other stars before reaching this one. In those distant passages, Atlast would have felt different magnetic fields and different solar winds pressing on its skin. Yet when Atlast finally entered the realm of our Sun, the structure of ThreeI Atlast held firm. No large fragments peeled away, no catastrophic jets tore Atlast into separate pieces. Near perihelion, the heat that often shatters ordinary comets washed over ThreeI Atlast without visible breakup. Where other bodies might split or shed massive chunks, Atlast showed only controlled shedding and a stable core. This resilience made ThreeI Atlast feel less like a fragile snowball and more like a seasoned traveller. Atlas behaved as if long journeys and harsh environments were not threats but familiar conditions. For some, that endurance hinted that ThreeI Atlast had either remarkable natural strength or thoughtful design. Either way, the survival of Atlast across such distances deepened the sense of meeting an experienced guest, not a naive wanderer. As Earth spun beneath quiet nights, people lay awake imagining the time before ThreeI Atlast appeared. In that unseen past, Atlast had already proven many times that it knew how to survive the dark. Across months of monitoring, the rhythm of ThreeI Atlast refused to stay confined to one kind of light. Optical telescopes saw the rise and fall of Atlast every 16 hours, steady as a metronome. Infrared instruments joined in detecting matching waves of warmth that brightened and faded in step with ThreeI Atlast. Preliminary radio logs hinted at subtle fluctuations that seemed to crest and dip on the same schedule as Atlast. When researchers overlaid the curves, they found a single heartbeat traced across multiple bands from ThreeI Atlast. The coherence made Atlast look less like a noisy comet and more like a synchronized system. Attention then returned to the jets seen near ThreeI Atlast, those narrow plumes carving through the coma. Under simple solar heating, jets should blossom from sunlit regions following where the star's energy strikes Atlast most directly. Yet frame after frame showed ThreeI Atlast launching some jets from regions that should have been cooling or shaded. Other plumes from Atlast pointed in directions that did not match the expected pressure of sunlight and spin. Models that forced strict solar control could not keep the jets of ThreeI Atlast aligned with theory. Only when the simulations allowed timed releases as if vents on Atlast were choosing when to fire did the pictures begin to resemble the sky. For the teams watching this did not prove conscious control inside ThreeI Atlast, but the multi-wavelength harmony and unruly jets together made Atlast feel orchestrated rather than purely weather-driven. That sense of orchestration nudged the discussion about ThreeI Atlast toward more daring possibilities. In the next analyses, the idea of Atlast as a technological construct would be spoken aloud more often, even if only in cautious tones. By the time all the clues were laid out together, the conversation around ThreeI Atlast had quietly shifted. What began as cautious talk about an unusual comet now included slides where Atlast was drawn as a deliberate construct rather than a lump of ice. On those charts, the orbit of ThreeI Atlast sat beside its metallic spectrum, the triplet logic, and the geomagnetic operation at L2. Each feature of Atlast could in theory be explained by a stretched natural model, but the stack of adjustments grew tall and uneasy. People began to ask what ThreeI Atlast would look like if it were from the start a technological object. In that frame, the controlled course of Atlast resembled navigation, the radio sheath resembled a network, and the convoy looked like an escort pattern. The field architecture around ThreeI Atlast, once just a puzzle of gradients, took on the character of a protective shell. The beam from Atlas to Earth's magnetic field read like an applied routine, a function executed and then shut down. In meetings, no one claimed to know who might have built ThreeI Atlast or when. Instead, they spoke of Atlast as a test case that strained the boundary between what nature could do alone and what might require coordination. For some listeners, the technological hypothesis made ThreeI Atlast feel less frightening and more comprehensible. A designed Atlas could be imagined as following a mission profile, not acting on unexplained whims. Others felt a softer unease at the thought of ThreeI Atlast as part of a larger unseen system. If Atlast was one node in a network, then its visit to Earth's neighbourhood might not be a unique accident. In the end, the hypothesis about ThreeI Atlast remained formally unproven but impossible to ignore. That unresolved status pushed the discussion of Atlast toward a new phase where clear tests would be needed to separate imagination from measurement. In the end, the debates about ThreeI Atlast narrowed down to a simple, quiet question. Could a few clear measurements taken in time tell whether Atlast was merely strange or truly orchestrated? Teams proposed 3 tests that together would frame the behaviour of ThreeI Atlast like a small experiment. The first was to track whether the 16-16-hour cycle of Atlast stayed locked with the same precision to the very end. If thermal changes or random jets drove the rhythm of ThreeI Atlast, tiny drifts should accumulate. If Atlast behaved like a programmed system, the phase might remain unnaturally exact despite changing conditions. The second test examined the jets of ThreeI Atlast more closely against the map of sunlight. By modelling local heating and spin, observers could see whether vents on Atlast truly followed the star's touch, or sometimes fired against expectation. A third test looked for radio features tied to the light curve of ThreeI Atlast. If the brightness of Atlast rose and fell in step with subtle modulations in the signal that would hint at deeper coordination. None of these checks required new physics. They only asked that ThreeI Atlast be watched attentively and in time. The real difficulty lay in the shrinking window as Atlast moved into geometries that would soon blind or muffle the instruments. To miss the window meant letting ThreeI Atlast pass with key questions left hanging between graphs and guesswork. Decades might go by before another visitor like Atlast offered such a clean if fleeting chance. For those awake with the data, the risk did not feel like danger from ThreeI Atlast. It felt like the softer loss of never quite knowing how far nature alone could have taken Atlast, or whether someone had helped shape its path. By the time ThreeI Atlast finished the geomagnetic operation at L2, the solar system felt strangely unchanged. The planets still followed their long ellipses, the sun still burned with the same quiet fury, and yet Atlast had left a faint new question in the background. From one perspective, ThreeI Atlast looked like a passing stranger, a guest whose path happened to brush the orbit of Earth. In that frame, Atlast arrived, shed gas, flashed a peculiar spectrum, and departed just another odd chapter in the long book of celestial visitors. From another angle, ThreeI Atlast resembled a maintenance craft arriving on schedule running a diagnostic on Earth's magnetic shield. The beam at L2, the triplet logic, and the careful non-contact boundary suggested a routine carried out by Atlast with practiced economy. In this second story, ThreeI Atlast was not here for greetings or pageantry. Atlast simply checked conditions, adjusted parameters, and moved on like a technician tending a system designed to last longer than any civilization. Scientists mapping those narratives never fully agreed on which version fit ThreeI Atlast best. Some preferred to see Atlast as a natural experiment and edge case that stretched known models without breaking them. Others found more comfort in the idea of ThreeI Atlast as a tool following instructions, a device whose grace came from design. For those listeners, Atlast felt less like a threat and more like evidence that care could exist on scales far beyond human reach. Outside those rooms, most people only knew ThreeI Atlast as a faint temporary name in the news. The deeper layers of Atlast fields, codes and quiet acts of adjustment remained folded into technical reports and private notebooks. Yet the presence of ThreeI Atlast touched anyone who paused to imagine the scene at L2. In that mental picture, Earth turned slowly, wrapped in an invisible field that had just been smoothed by Atlast under a sky unchanged to the human eye. As ThreeI Atlast dimmed and accelerated toward deep space, the immediate story ended, but the larger question stayed open. Was Atlast only passing through, or had Earth just received a visit from something that keeps watch over fragile worlds? No one needed to answer before sleep. ThreeI Atlast was already far away, the planet was still turning, and the question could drift with each listener into the dark, waiting patiently. like Atlast for another orbit, another night, another chance to be considered.